Welcome back. The topic that we're going to discuss today is intermolecular forces. Okay, and before we actually get into the topic, I have some major questions like I had for when we talked about colligative properties. The concept of intermolecular forces is very much in tune with what we learned in colligative properties. So everything you learn here, you would see some implications there, and everything you've seen in colligative properties, you would see implications of intermolecular forces. So they are in a way interrelated. Okay, so there is one question that I want to touch back from colligative properties, which is, this is not one of the major questions I posted right up front when we started colligative properties. This is just an extension of a question. So why does adding a solute lowers the vapor pressure of a solvent such as water and makes it boil at a higher temperature than pure solvent or pure water by itself? Now, if you remember when I talked about colligative properties, I said that when you add a solute to a solvent, its vapor pressure is lowered, which means it's going to take a lot longer for that liquid to boil, right? Compared to pure water, when it doesn't have any solute or any impurities to it, then it boils at 100 degrees, right? So why is that the case? Let's see if we can answer that through this topic here. And if you recount from Chem 170, based on electronegativity difference, nitrogen and oxygen are nonpolar. You don't believe me? Go pick up your electronegativity table and solve the math. You would see that they have a difference of 0. This implies they are nonpolar, right? If they're nonpolar and they can be subject to too many things, why can't they be liquefied then? You can have nitrogen as a gas or as a liquid. So is oxygen, which can be a gas or liquid. In fact, liquid oxygen looks beautiful, unlike liquid nitrogen, which is just bunch of like a foggy appearance to it. Oxygen, on the other hand, is beautiful. It's got that light blue color tinge to it. So why can't they be liquefied? And why is it not recommended to hydrate oneself by consuming snow when stranded in a snow blizzard? Why does a burn caused by, it should be steam, not snow. I don't think snow can cause any burns. Why a burn caused by steam is more serious than a boiling water? So hopefully you'll find some answers to these questions as we move forward with the topic on intermolecular forces. Now, just like we had 4 components to colligative properties, there are obviously four components. It's coincidental that there are 4 major components to intermolecular forces as well. One of them is dipole-dipole interactions. Second is London dispersion forces. Third is hydrogen bonding. Fourth is ion-dipole interactions. And you should be glad in one way that this entire topic on intermolecular forces doesn't require you to solve any math problems. However, approach all questions related to the topic in a more conceptual way, that is, lack of any mathematical work. So this is much easier. And then as a side note to the topic, we're going to look at the implications of intermolecular forces on some of the basic concepts we run into everyday life, which is cohesion, adhesion, and viscosity. All right, so I'm going to try to keep the remainder of the videos very short, because you only want to understand the concept. As I said, there's not going to be any mathematical problems associated with this topic. It's, if you understand what it is that I'm saying, then you're good. You don't need to do any problems to do it. However, we may have some conceptual problems, which is how is one better than the other kind of questions on this topic. So that's what I want to focus on the remainder of the videos. As like my previous topic video on colligative properties, I want to keep the first video to just introducing the topic in general, and then talk more detail about each of those components in the remainder of the videos. So I'll try my best to keep the videos less than 10 minutes. So stay tuned for the components of intermolecular forces.